Okay, so we're starting chapter 4, and it's called functions, and it's really going to be a lot of what we did last chapter, but just putting a new name or a new spin on it. So, tables, graphs, and equations. We've worked with all of those. Recall that an equation is a mathematical sentence stating that two quantities are equals, so y equals something. A linear equation is an equation with a graph that is a straight line, hence linear. Some equations contain more than one variable. What equation did we just learn that's always a line? Y equals mx plus b. Or sometimes it doesn't have a b, it starts at the origin. So m was the slope, b is the y-intercept. Or this is how it changes, the constant rate of change. This is where it starts on the graph. So, looking over here, slide 2. To achieve orbit, a space shuttle must travel at a rate of about 5 miles per second. That tells us something. The table shows the total distance d that the craft covers in certain periods of time t. Write an expression for the distance in miles. So the distance is equal to, looks like if we found its change by dividing the outside or the inside, we would get 5 every 1 second. So 5 per time. Describe the relationship in words. The distance, miles, is increased by 5 miles per second. Or we could have just said 5 miles per second. Would have been way easier. Graph the order of pairs. Describe the shape of the graph. So, our miles depends on our time. So miles or distance will be our y-axis. Depends on our time. Ordered pairs 1, 5, 2, 10, 3, 15, 4, 20. We could keep going. So it is a straight line. This would be y equals 5x because it starts at 0. 0 miles, or 0 seconds, 0 miles. It's a straight line. Slide 3. We're going to write an equation this time to find the number of liters in any number of quarts. Describe the relationship in words. So find the rate of change or the slope and describe and interpret it. So that would be this distance here. Looks like it's going up 0.95 liters per quart. So step 1, find the slope. We did. It's 0.95 liters for every 1 quart. Liters per 1 quart. Write an equation using the given variables. They want us to use Q and T. So we know that the quarts are equal to 0.95 times L. So 0.195 times 1 time, I have this backwards. The L is equal to 0.95 Q because we multiply by the number of quarts to get our liters. 1 times 1 is this, times 2 is this, times 3, yeah, there we go. About how many liters are in 8 quarts, so we could say liters is equal to 0.95 times 8, which we can figure that out with 7.6. 7.6 liters. Okay. Looking at this next one, the total cost of tickets to the school play is shown on the table. Write an equation to find the number of tickets. So we can use these variables. Let's find our slope or our constant rate of change. Looks like it's $4.50 for every 1 ticket every time. So find the rate of change or the slope. So we did $4.50. It's $4.50 per ticket. Write an equation using the given variables. So the cost is equal to 4.5 per ticket. Use the equation to find the cost of 15 tickets. So plug and chug. 4.5 times 15. Right now all of these have a y-intercept of 0. They start at the origin. So that's why it's similar to y equals mx. $67.50. There's no initial fees in these, though. Okay, trying it again, but this time we're given a graph. The total distance Marlon ran in 1 week is shown in the graph. Write an equation to find the number of miles run y. So this one is a y equals mx. So find the rate of change. So how much does it change? From 3.5 to 7 to 10.5. It would be 3.5. So y equals 3.5 miles per day. Write the equation. Oh, whoops. We did that right here. So find the rate of change. Whoops. That's 3.5 miles per day. And in slope-intercept form is y equals 3.5x. How many miles will Marlon run in 2 weeks? Well, 2 weeks is 14 days. So y equals 3.5 times 14. I have to use that 14 because this is per day, not per week. So I need to change it to days. So 3.5 times 14 days. 49 miles in 2 weeks. All right. Similar here, the number of trees saved by recycling paper is shown. Write an equation to find the total number of trees y can be saved for tons of paper. So in how much is that? How many tons are we saving? 17 tons per tree. Wow. So the rate of change is 17 tons per tree, which would be y equals 17x. Use the equation to find how many trees can be saved if 500 tons of paper are recycled. That 500 tons is our x value, so y equals 17 times x, or 500 in this case. And that looks like it is 8,500 trees. That's a lot of trees. Go and recycle. It's good for the planet. Okay. Chloe competes in jump rope competitions. Her average rate is 225 jumps per minute. So this is our slope, our constant rate of change, our m, all of those things. Write an equation to find the number of jumps in any number of minutes. So jumps is y equals 225 per minute, or x, I guess. Some people like to use something like this, per minute. Those are equivalent, but I think this one's easier to graph because it has y and x. Make a table to find the number of jumps in 1, 2, 3, 4, 5, then graph. So 1 minute, these would be minutes. 1, 2, 4, 5, and jumps. 225, 450, 675, 900, 1125. So then we would graph them. We're going to have to do some estimating, but we would graph them. And then we'd have a straight line because it has a constant rate of change. A library charges $3.50 plus 15 cents per day. The book is returned as late. Write an equation to find the total late fee, F. So what's it cost per day? 15 cents per day. This one's a little bit different because it also charges $3.50. So this one has an initial fee. Make a table to find the total fee if the book is 10, 15, 20, or 25 days late. 10, 15, 20, or 25. So we're going to plug and chug here. 0.15 times 10 plus 350. Well, this is $1.50 plus 350 would be $5. 0.15 times 15 days. I don't know what that is, so I got $2.25 plus 350 is $5.75. 0.15 times 20, well, that's $3 plus 350. $3 plus 350 is $6.50. These are going up by 75 cents each time. So this one would be $7.25 for every 5 days. And we would graph it 10 and 5, 15 and 5, kind of estimating, 20 and 650, 25 and 725. So this is days and cost. So it's a lot of what we've been doing, just more word problems, more real life scenarios. So there we have it.